In this video, we will be discussing the quadratic function and analyze its graph. A quadratic function is a function with equation of this form. For quadratic function, the highest power of the variable x is 2. A, b and c are constants, and a will never be equal to 0 because if a is 0, then the equation will be linear and not quadratic. A more useful form of the quadratic function, however, is the vertex form. A quadratic function will always form a parabola. The vertex of a parabola is the point where the parabola reaches its minimum or maximum value. The value of the vertex is given by the constants h and k in the vertex form. H is the x-coordinate of the vertex and k is the y-coordinate of the vertex. The a constant is same as the one in the standard form. Let's now see how these constants affect the graph of the quadratic function with some examples. First, we have a simplest form of the quadratic function where a is 1 and h and k are 0. The graph of this function will be a parabola that opens upwards because a is positive. And since h and k are 0, the vertex of the parabola will be at the origin. If we just flip the sign of a, the parabola will be reflected across the x-axis and will open downwards. If we increase the value of a, the parabola will be stretched vertically and become narrower. And likewise, if we decrease the value of a, the parabola will become wider. Next, let's see how changing the vertex constants affect the graph, starting with h. If we increase the value of h, the parabola will shift to the right and thereby changing the location of the vertex as well. If we decrease the value of h, the parabola will shift to the left. If we increase the value of k, the parabola will shift up. And if we decrease the value of k, the parabola will shift down. I hope you now got a good understanding of how different parameters of the quadratic function affect its graph. Now let's use this knowledge to graph a quadratic function using the transformations we just discussed. Let's say we want to graph this quadratic function. Notice that the equation is already in the vertex form. From the equation we can see that the value of h is 1 and the value of k is 2. Now let's graph the function step by step. First, we will graph the function without any transformations applied. Next, we will change the sign of a to negative to match the function in the equation. As we know by now, this will reflect the parabola across the x-axis. Now we will increase the value of a to 2 as in the equation. This will stretch the parabola vertically and make it narrower. Next, we will subtract 1 from x, which will shift the parabola to the right by 1 unit. Finally, we will add 2 to the function, which will shift the parabola up by 2 units. And there you have it. We have successfully graphed the quadratic function using the transformations we discussed earlier. You might be wondering, what if the quadratic function is not in the vertex form, but in the standard form? How do we find the vertex of the parabola in that case? There are actually a couple of formulas that can help us find the vertex of the parabola using the constants of the standard form. If you are curious how these formulas are derived, I am leaving the proof here for you to check out. I will not be going through the proof in this video as it is simple algebraic manipulation. Now let's take an example of a quadratic function in the standard form and find the vertex of the parabola. Using the formulas we just discussed, we can find that the vertex of the parabola is at 1 and 0. The a constant will remain the same as in the standard form. Now since we have all the constants of the vertex form, we should be able to graph the function. And that's the end of this video. I hope you found it helpful and learned something new about the quadratic function. If yes, then please consider subscribing to the channel and hit the like button. In the next video, we'll take a look at polynomial functions in general. Thank you for watching.